So we are rapidly approaching the end of this course, and while you may be a bit relieved after having endured calculus, don't slack off yet. Use substitution. What we're going to be looking at over the next couple of assignments is going to be one of the most important tools that I teach you this term, mainly because it's really our tool, the method by which we find the antiderivative for more complicated problems. Okay, so I know that was a mouthful. I think once you see some of the problems, you'll really understand exactly what I'm talking about. So in this problem, or in this PowerPoint, we're really looking at substitution and the power rule. We're going to look at some other integrals. We're going to look at how to do substitution with trig functions and exponential functions, and we're going to look at those in just video by video. We're not going to tackle it all at one time. So let's jump in here and take a look, right? Just there's some minor reading we want to do. Let me get my pen ready here because there are some things I want to highlight. We're going to be looking at a technique called integration by substitution. This method helps us find antiderivatives when the integrand is the result of a chain rule derivative. Okay, so remember that the integrand is this thing, so that's the integral sign. And then this little thing right here, that whatever we're taking the antiderivative of, that is the integrand. We call this method substitution because what we're going to do is replace the integrand, right? We substitute part of the integrand with the variable u and part of the integrand with du. So we're gonna be focusing on this section. What is u, okay? And then how do we find du? Okay, so one thing to remember is that you will choose u, okay? To find du, we're going to take a derivative. Take the derivative. So really the only thing you're choosing is what we determine u to equal. Du is going to be determined by the derivative of whatever u is. Okay, so here's a mathematical breakdown of the chain rule, and there are some guidelines by which we want to operate by. The basic procedures. I'll let you read those on your own. You can see the PowerPoint in the next page in Canvas. I want to focus on how do we actually do one of these problems. There's several examples here, and I don't want to make this video too long, but I do want to make sure you have a good foundation. So this says use substitution to find the antiderivative of this function, right? So if we were to draw this out, and we've got it written right here, there's a text error in the PowerPoint, so let me draw this for you. It would be the integral of 3x squared, and I'm going to do this on purpose, x squared minus, x cubed minus 3, okay? And then out here we have dx. Now notice that that was not in the original problem, but when I put the integrand here, we have to have the dx there. So here's what I want to point out. In this problem, we tell you, let u equal x to the third minus 3. One of the big questions you're going to have this section, right, as you go throughout these homework problems is, what is u, right? That's what we're really going to be struggling with, trying to figure out, what do I let u equal? So let me give you the Mr. Stark, Central Alabama, this is how I taught definition of what u should be. Okay, you ready? U, I got a little autosave going on here. Y'all forgive me with the spinning wheel of death here. There we go. U equals the thing raised, that word is raised to a power, okay? So you can read all about what u is supposed to equal, or if you just use, down home country boy kind of talk, right? This is what we got, right? U is the thing that is being raised to a power. Now, sometimes that's hard to tell. So another way of looking at u is to say that u is the thing under the radical, right? So under the square root or the cube root or what have you. And again, these are just, you're not going to read this in a book. This is just going to be what I suggest. So when you're doing a problem on your own and you're having to determine what on earth should I let u equal, look for these two hints to help you decide what that is. Now, in this problem, we tell you that u is equal to x to the third minus 3. I'm going to go in now and I'm going to say, well, if u is equal to x to the third minus 3, du would simply be the derivative of this thing. So the derivative of this is 3x to the second dx, okay? So I've got to make some substitutions. And what I want you to notice is that in my problem, I have u, okay? So u is x to the third minus 3. I have that raised to the second power. My new integral is going to be the integral of u raised to the second power. Now we can't just plug du in. We've got to look to see, what does du equal? Well, du equals 3x squared dx. And look in my problem, I've got 3x squared dx. So now that I see this expression is equivalent to du, I can replace that with du. So the antiderivative of u squared, right, you can see that worked out right here. It's u to the third over 3 plus c. And then we're going to plug back in our value for u to get this final integral, x to the third minus 3 to the third power over 3 plus c. There's something important we want to note right here. In a lot of our problems, the differential du differs from what would match up in the integrand by some constant factor. So I don't want you to get too lost in that. It's kind of, it's kind of difficult to read. The point is, sometimes what we get right here doesn't always exactly match what we have here. And we're going to look at that in the next example. So let's take a look at this this problem. Well, excuse me, this example. If we look at this one right quick, this is just a repeat of what we did in the last problem. And you'll recall that one of the things I told you was that u would be the thing under the radical. So in this case, the thing under the radical is 1 plus x to the third. Du would be the derivative of that, 3x squared dx. So again, in our problem, you'll notice we have 3x squared dx, and we're replacing that with du. And then we have the square root of, right? That's our u, okay? So what I want to make sure you understand is what happens when what I find for du doesn't exactly match the problem. In this question, I say, find the derivative of 2x to the third times x to the fourth minus 1, okay? So your thing would probably be, well, Mr. Stark, you said to let u equal the thing that was raised to a power. So again, that's a rule of thumb, not something you're going to read in a math book. There is an understood 1 right here. So technically, my definition would hold. However, another rule of thumb could be that u is the thing inside the parentheses. Okay, so in this case, u is x to the fourth minus 1. Now, probably a more technical way of saying this is that to identify u, see if you can identify its derivative in the problem, right? So if I let u equal 2x to the third, the derivative of that would be 6x squared. And unfortunately, I don't have any x squareds in my original problem. But if I let u equal x to the fourth, then the derivative of that is 4x to the third dx. And you'll notice in my original problem, I've got x to the third, right? So that's another way I can figure out what u is. Now, here's what's interesting, okay? If you notice, I have x to the fourth minus 1, and that can be replaced by u. I cannot replace 2x to the third dx, I can't replace that with du because du does not equal this. Du equals 4x to the third dx. So notice what we do. We're going to take dx and identify dx to be du over 4x to the third. And that's what's happened in this situation here. I no longer write dx, I write du over 4x to the third. Okay? Now I haven't replaced this guy yet. It's just still floating there, and you'll notice that the x to the thirds cancel. The 2 and the 4 cancel, and we're left with a 1/2 u du. And that thing is easy to take the antiderivative of. It's 1/2 u squared over 2 plus c, or 1/4, right, u squared plus c. So plugging back in for u, I get 1/4 x to the 4th minus 1 squared plus c, right? That's the integral of the problem. And I think you're able to see now how to do this when du doesn't actually show up, right? Doesn't show up. So in the last problem, we were able to simply replace 3x squared dx with du because they were equivalent. And in this case, that doesn't apply anymore. If you remember in the last couple of problems, we were working with indefinite integrals. Well, now we have these definite integrals, right? Because we have a and b here. And so the thing that you need to understand about a definite integral is that the a and b are values. These are values for x. Well, when we replace this thing with u's, now we need values for u, not values for x. So in the next couple of problems, we're going to look at how do we do problems with definite integrals and substitution. So think about this problem. We're gonna evaluate, right? In other words, tell me what this thing equals. To evaluate this, I have to find the antiderivative of this expression. And I suggested that you let u be the thing that's being raised to a power, right? So if you look, this thing is being raised to the 5th power. So we're going to let u equal 1 plus 2x to the third. And that makes du equal to 6x squared dx. And if we look around, we notice that we don't have that 6x squared. So I'm gonna say dx is equal to du over 6x squared. Okay, so if I rewrite my integral, it's going to look a little bit like this. I've got the x squared times u to the 5th, right, because we're not writing this anymore, times du over 6x squared. And what will the x squareds do? Well, of course, the x squareds are going to cancel. And my new neat integral now is the integral of 1/6 u to the 5th du. But remember, we're looking for the definite integral, right? Where we have a 1 and a 0. Now, I'm not going to put 0 and 1 right here. That is bad because 0 and 1 are values for x. And my expression now has u's in it. If you recall, u is equal to 1 plus 2x to the third. So what we're going to do is we're going to let u equal 1 plus 2 times 0 to the third. Well, that's going to equal 1 plus 0, or just 1. Now notice I plugged in 0 for x, right? I plugged in 0 for x. So on the bottom here, I'm not going to have 0 anymore. I'm going to have 1 because that's what this thing's equal to, right? I'm going to go over here and I'm going to let u equal 1 plus 2 times 1 to the third. And that's going to equal 1 plus 2, or 3. So my boundary up here is going to be 3. Well, we're going to go in and do the antiderivative of u to the 1/6 u to the 5th. That's going to be 1/6 u to the 6 over 6, or u to the 6 over 36. And we're not going to plug 0 and 1 in. We're going to plug 1 and 3 in. Now, the Newton PowerPoint is already simplified. Let me kind of show you what happens. We're going to have 3 to the 6th power over 36 minus 1 over 36. So these fractions already have common denominators. I just need to know what 3 to the 6th power is. So I'm going to launch my calculator. See if we can't figure out 3 to the 6th power. Now we're going to subtract 1, right? Minus 1. And we get 728 over 36. 728 over 36. Math teachers and math homework does not like things that have not been simplified. So I can start just by dividing both of these by 2 since they're even. I'm going to go ahead and try to divide both of them by 4. And I get 104 over 36. So let's see. I'm just double checking my work because it's not matching up with what the Newton PowerPoint has. Yeah, I don't see where that is. I wonder where they're getting 182. So let's divide by 182 here. Okay, so maybe I did some math. Maybe I didn't do something right. Let's double check. 728 divided by 4 is 182. Okay, so I don't know what I hit or what I typed incorrectly. Yeah, so our answer is going to be 182 over 9. Here's another one that works very similar to what we just did. I'll leave you to look at that one on your own. We probably need to look at this one together just to make sure things are working the way they should and you understand kind of how things go. So I'm going to go and I'm going to say, let's figure out what u is supposed to be. So if we look at this one, we can say, well, x to the third isn't raised to a power and it's not under a radical, but it is inside parentheses. So we're going to pretend that u is equal to x to the third, and that would make du 3x to the second dx, okay? So you'll notice that in this case, I do have my u and my du showing up exactly the way it should. So we're going to have the integral of u du if we make the appropriate substitutions. Now the other thing to recall is that these values right here, these boundaries, those are for x. So if I want to know what u should equal, I'm going to have 1 to the third and I'm going to have negative 1 to the third. In other words, I'm plugging these values in to whatever u is. And it turns out that in this case, there's still 1 and negative 1. Excuse me. So I'm going to take the antiderivative of u, which is u to the 1 plus 1 over 1 plus 1, or 1/2 u squared. And we're going to plug in negative 1 and 1. So 1/2 of 1 squared minus negative 1 squared. So what's happened is we've factored out this 1/2. And we're going to have 1/2 of 0, which is 0. So all of the problems in this first Newton assignment are going to focus on how we do u substitution when we have an integral that looks like this. U to the n du equals u to the n plus 1 over n plus 1. And in some cases, we have to change those boundaries right here, right? Now, in the next video, or in the next couple of videos, we're going to be talking how to take the antiderivative of sine 3x dx, right? So we're going to use this substitution when we look at some trig integrals, and then subsequently with the exponential and logarithmic integrals as well. Good luck with this. Hope to hear from you.